So this video is really a continuation of my last video on integration by parts. I wanted to address a couple of things that I didn't get to address in the previous video. And in that previous video, we introduced the sort of main approach to integration by parts and the integration by parts equation. And what you always want to do is try to choose your U choice first. You want to pick one of your equations as U. And the one you pick as U should have the easier derivative. So in this case, you would want to pick this guy as your U because the derivative of that U would be quite simple as compared to the derivative of this U here, which would make the rest of this the cosine x dx dv. Now, like I said in the last video, there are certain situations in you can't tell which U to choose because the derivative of both options are pretty simple. Take this problem as an example. If I choose the x cubed as my U, well, derivative of x cubed, 3x squared, well, that's pretty easy. If I choose the natural log of x as my U, derivative of that is 1 over x. So that's kind of simple too. So which one do I choose as my U? So I can't quite tell, which means now I would move to step 2. I would try to make my U dv choice based on dv. So we have to look at which equation has the most simple antiderivative. So if I chose x cubed as my dv, antiderivative of that, x to the 4 over 4. Alright, why not? And for the natural log of x, antiderivative of that, well, actually I can't think of an antiderivative for that. So, in this case, x cubed would be my dv choice, which would make ln of x my u choice. So my u, natural log of x, and my dv would be the x cubed dx. And remember that when you make your dv choice, you have to include that dx term in there. And of course, I would take the derivative of my u to get my du, like I need here. And I would take the antiderivative of my dv choice to get my v, like I need here. And I would just continue on with my integration by parts recipe. And it actually wouldn't be too hard running with these u and dv choices. So that's one of the things I just wanted to show you. If you aren't able to make your u choice, if both choices of u have a simple derivative, move on to step 2. Make your choice based on dv. Look for the equation that has the simplest antiderivative. So the other thing I wanted to address was this right here. The fact that there are plenty of exceptions to the sort of general format that integration by parts is used when two equations are getting multiplied. Like right here. You could use integration by parts on this guy. And in this case, this has to be your u. And there's only one equation here. You can't make this your u because you can't take the derivative of, this differential there. That wouldn't make sense. So u would be natural log of 2x plus 1, which means by default, this would have to be dv, the dx term. That might seem a little weird, but it actually works out nicely. dv is equal to dx. You got to take the integral of both sides, which gets you v over here and x over here. And there you go. And of course, the derivative of that u, doing the chain rule, would be this. So now you could carry out your integration by parts recipe and you could get to your right answer. So that's it. I just wanted to cover those two things. What happens if we can't make our u dv choice based on the u, based on which equation has the easier derivative. In that case, you would just move on to step 2. And I also wanted to address what you do when you use integration by parts on an equation that just is made up of one equation, rather than two equations getting multiplied by each other.